All right, the last video kind of cut me off a little bit. So this is what's called the Schwarzschild radius. The Schwarzschild radius is basically the size of the black hole. So I'll go through some examples with this a little bit later. So big G is called the universal gravitational constant. Its value is 6.67 times 10 to the minus 11th. The mass is really the only variable. So the mass has to be in kilograms, and then c is the speed of light. You use this number right here, but of course you have to square it. So g and c are always the same number, and then the radius will be in meters. All right, so like for example, this is now look. Not everything can become a black hole, even though you can do this calculation. Like for example, you could do the calculation for the Earth. If you plugged in the mass of the Earth here, which is roughly 6 times 10, 6 to the 20, sorry, 6 times 10 to the 24th kilograms, the size of the Earth would be about one tenth of a meter. All right, so one tenth of a meter is of course a centimeter. So it'd be about the size of about a centimeter in size. Now, there's no way for the Earth to squeeze down to that size, right? It's only, really massive dead stars, stars that start out way more massive than the sun and end up 3 times the mass of the sun. Whatever's remaining after the explosion of the supernova, then that star could become a black hole. All right, so even though this is a relatively simple equation and can be applied to anything with a mass m, it's only really applicable for things that are 3 times the mass of the sun or greater after fusion has stopped, for a dead star, right? That's what we mean by a dead star. All right, so now we turn to galaxies. So galaxies are incredible collections of stars. We live in a galaxy. It's called the Milky Way. This is actually a nice picture of the Milky Way. This is a little enhanced. They always show you enhanced pictures. That looks like a comet right there. I don't know why they have a comet that they're showing you right here. But anyhow, comets are part of our solar system, right? That's there's so many stars here that they collectively look like a band of light. This band appears in the same locations in the sky, night after night after night, year after year. And of course, the Greeks were the first to call it the Milky Way, and that name has stuck. In fact, right around here, where I'm pointing to, is the direction of Sagittarius. That just happens to be the constellation that lies. The thickest part of the Milky Way lies in, and of course that is the direction of the center of the Milky Way. Sagittarius is the direction of the center of the Milky Way. There is actually another object there at the center of the Milky Way, it turns out, and it's a black hole. So up to this point, we talked about what are called stellar black holes, a single star that has a mass far, far greater than the sun. Maybe 20 times the mass of the sun, and then when it dies, that's what we were talking about. It dies. It has, let's say, what's remaining has a mass of 3 times the mass of the sun or more. That dead star becomes a black hole. But at the center of the Milky Way, and this is actually the first one that was ever discovered, is a supermassive black hole. And that supermassive black hole, the one at the center of our galaxy, turns out to be one of the smaller supermassive black holes that are out there. In fact, all galaxies, all really large galaxies, seem to have supermassive black holes at their center. The one at the center of the Milky Way is about 4 million times the mass of the sun. And around in the center of other galaxies, there are some supermassive black holes that have a mass of billions of times the mass of the sun. So, anyhow, So that this is the Milky. This is kind of what it looks. You'd have to be in a very dark region to see the Milky Way. Um, at any rate, and this little hazy patch down here is actually one of the clouds of Magellan. All right, so there's these two satellite galaxies. They're little tiny dwarf galaxies that are orbiting the Milky Way, and that's one of them called the. I think that's the larger one, the large cloud of Magellan. All right. There are other types of galaxies out there. So this one is called an elliptical. This picture right here is showing you an elliptical galaxy. You can see that there's some activity here where there's some jet of material that actually is moving really close to the speed of light, ejected out at the center of that galaxy. Um, that galaxy is called M87. And by the way, we've seen the supermassive black hole at the center of this galaxy. There's a telescope that is basically this. It's multiple telescopes that are combined to basically be about the size of the Earth, and it's called the Event Horizon telescope, and so it is actually taken a picture. It's actually rather famous. A picture of the supermassive black hole at the center of M87. All right. So irregular galaxies, spiral galaxies, of course, that's the one that we live in is a spiral galaxy. In fact, we live in what's called a barred spiral. We'll talk about that a little bit more. And then there's these irregular galaxies, like for example, the large and small clouds of Magellan are irregular galaxies. All right. Yeah, there they are right there. There's the large one. There's the smaller one. You can only see these in the southern hemisphere. These are just two of them. I mean, there's lots and lots of these out there in the universe. These two are gravitationally bound to the Milky Way. This is a spiral galaxy. You can't really see the Milky Way like this because it would take, for example, the distance between the most distant part of the Milky Way and the opposite side, the diameter, if you will, of the Milky Way is about 100,000 light years. So so the size of the Milky Way is roughly 100,000 light years across. So we live way, way out here. If this is the center of the Milky Way, this is not the Milky Way, of course. We're just representing this as the Milky Way. If we were to represent where our sun would be right about right here, and where the sun is about 26,000 light years from the center of the Milky Way. All right, so there's a spiral very similar to the Milky Way. Let's see, galaxies are not the largest things in the universe. So galaxies will actually cluster. So when they cluster, that means that they're gravitationally attracted to other galaxies, and those clusters are actually can the clusters themselves can cluster together into what's called a supercluster. All right, so these are like clusters of galaxies, and our local supercluster is called the Virgo supercluster. So we live in the Virgo supercluster. Our local group of galaxies, it's not shown here, but our local group is literally called, it doesn't have a very imaginative name, the local group. That's what it's called. And so the local group it's not even a cluster of galaxies. Clusters usually have mixtures of spirals and ellipticals, and also some of course, some of the irregular galaxies. Let's see. So then some of the galaxies, in fact, we just encountered one, M87, have an active nucleus. In fact, they're called AGNs, active galactic nuclei, where there's incredible amounts of energy pouring from these galaxies, much more than like your typical average galaxy. Like, if this represents the Milky Way, there's a certain amount of energy coming from it. But then you go to M87, which is an active galaxy, and there's active galaxies can be elliptical. They can also be spirals. You can even have irregular galaxies that are active. So the active part, by the way, we actually now understand that. We didn't understand it before, but here, let's see if it talks about it. So one of them is what's called a starburst galaxy, and so in that, it's usually two galaxies that have collided in undergoing galactic collisions, and during that galactic collision, you might remember I mentioned the fact that there's all these gas clouds that just haven't collapsed into stars. And by the way, the clouds, and I didn't really say this with enough emphasis. When a cloud, one of these giant gas clouds collapses, it collapses into multiple stars, right? You can have like, for example, in the belt of Orion, there's the Orion Nebula. There are multiple stars, hundreds perhaps of stars coming from the Orion Nebula. All right, so when you have two galaxies colliding, you have all that gas and dust that gets disturbed and begins to gravitationally collapse, and so you'll have an incredible burst of star formation from those clouds, from those gas clouds, and so that's called a starburst galaxy. So these active galactic nuclei, that's different from a starburst galaxy, like, for example, M87. What that is a supermassive black hole at the center that is undergoing a feeding stage. So there's tremendous amounts of material that is falling into this black hole, this supermassive black hole at the center, and causing tremendous amounts of energy to come flying out, and that's the active galactic. And so there's energy flowing in, and there's also this material starts going around the black hole in an area called an accretion disk, and that accretion disk, the material rubs against itself, it rubs against the other material, and it heats up dramatically, and that releases tremendous amounts of energy. All right, so that's what these active galactic nuclei are. The motion of individual stars in the galaxy normally follows elliptical orbits around the center, right? Yeah, that's exactly right. This is a nice picture of the local group. So it's the Milky Way. There's the large and small clouds of Magellan. There's a couple of little dwarf galaxies. Andromeda is another spiral galaxy. It's actually twice the size of the Milky Way, and they're actually, Andromeda and the Milky Way are on a collision course. Now it'll take billions upon billions of years for Andromeda and the Milky Way to collide with each other, but that will happen in the future. Here's another small spiral galaxy called Triangulum. So there's a few dozen other galaxies that form the local group, and the local group is not considered a cluster because it doesn't have any large elliptical galaxies. So here's the local supercluster. It's also known as the Virgo supercluster. It's not in a plane like this. It's a huge volume of space. There's another local cluster. They're usually named after the direction in the sky that they are, like what constellation they generally lie in. Like, for example, there's this is another constellation in the sky called Eridondus. So there happens to be a cluster in that area. Again, we're part of the Virgo supercluster. And then there are multiple superclusters all around like when you get an overall picture of the universe, these superclusters seem to exist in these gigantic filaments, if you will, throughout the universe, and then there, in between the supercluster, there are regions called voids where there's absolutely nothing, no no galaxy, no